Okay, let's look at the sum of the measures of the interior and exterior angles of convex polygons. So we just looked at the triangles, okay? We know that the sum of the interior angles is 180 degrees. But what's the sum of the exterior angles? Well, let's look at a triangle, and we're going to have to do a little bit of figuring. Because remember, supplementary, okay? Here's angle 1, 2, 3. So these things right here add up to 180. This adds up to 180. This adds up to 180. So if you think about it, I have 1, 2, 3 items that add up to 180. So I've got 3 times 180 minus, well, 180, right? Because the interior adds up to 180. So basically, if I think about this, it's 2 times 180, which is 360. So the sum of the exterior angles for a triangle is going to be 360 degrees. And I'm actually going to tell you that the sum of any regular polygon of the exterior angles is actually going to be 360 degrees. Does not matter how many sides it has. The sum of the exterior angles will be 360 degrees. Now the interior angles will change. The sum of those interior angles is going to change. And it changes by the number of sides it has. So let's look at a square, or let me not say a square, a four-sided figure, parallelogram, a quadrilateral, okay? Because it actually doesn't matter if it's a square, anything like that. I'm just going to do a parallelogram. Ugly looking parallelogram. But a parallelogram, okay? And so I know that the exterior adds up to 360. So if I think about this, I have this that adds up to 180. I have this that's going to add up to 180, 180, and 180. So I have 4 things that are going to add up to 180. But I have 1, 2, 3, 4 things out here that are total 360 degrees. So if I take that and subtract 360 degrees from it, because my exterior angles are all going to add up to 360, so 4 times 180 minus 360 will give me 360 degrees. So a four-sided figure, no matter what the original interior angles are, the sum of the interior angles will add up to 360 degrees. Let's look at a 5-sided and a 6-sided figure. Now remember, I told you that the sum of the exterior angles, and that's going to be a theorem that we're going to look at here in just a moment, is going to add up to 360. So I'm going to scroll down a little bit, and I'm going to look at a pentagon, the one that looks kind of like a house. Okay, I'm going to extend those sides just a little bit. And the reason I extend the sides a little bit is so that we can look at the interior and exterior angles. So I have these angles that are going to add up to 180. Interior, exterior that add up to 180. Interior, exterior, 180. 180 and 180. So I have 1, 2, 3, 4, 5. So 5 times 180 minus the 360, because my exterior angles add up to 360. So 5 times 180 minus 360 is going to give me 540 degrees. Let's look at a six-sided figure, the hexagon. So 1, 2, 3, 4, 5, and 6. Now I'll extend those sides. And again, if you think about it, I've got 1, 2, 3, 4, 5, 6. So I can do 6 times 180 minus the 360, and that's going to give me 720. Now if you'll notice, basically what we've done here is for every time we add a side, the interior is basically adding 180 degrees. There's a theorem that says the sum of the measures of the interior angles of any convex, now we have to pay attention, it will be a convex, can't be concave, polygon with n sides is going to be n minus 2, so we subtract 2 sides from it and multiply it by 180. So think about our 5-sided figure. So we take 5 minus 2 times 180. So that's 3 times 180, and that would give me the 540 degrees. It does not matter how many sides you have. This will give you the interior angles. Now, notice down here, just like I told you earlier, the sum of the exterior angles for a convex polygon is always going to be 360. And the reason why is, think about, you're basically creating a circle around. And so no matter, as long as it is a convex, you're creating that circle around. So you're going all the way around. Even whenever I look at my equilateral parallelogram and things like that, I'm going all the way around. So my exterior angles have to add up to 360 degrees. And so that's what this right here is actually looking at.